So for this video, we are going to be looking at some alternative algorithms for addition and subtraction. And then there will be a second video about alternative algorithms for multiplication and division. So there's lots of different ways and strategies we can think about for adding and subtracting. So this is just introducing you to some of these methods. Maybe you've seen some of them before, maybe you haven't. So if you look on page 67, I have this list of algorithms. So we're going to do them in base 10, and then we're going to be looking at if these algorithms work in other bases. So these are the problems that I am referencing throughout this video. So like I said, this is on page 67, and then you have blank paper in the following on your course pack. So on page 68, 69, 70, 71, and 72, 73. So you should have lots of space to be able to do these problems. So for the sake of the video, I've already written out what the problems are that we are going to look at. So if we start with page 68. So one of the methods we've already talked about for addition is a physical model. So using manipulatives to teach addition first and then moving into algorithms. So it's always good to do hands-on things with kids first and then move away from those hands-on manipulatives and then start just having them work with numbers. So this should just be review. You've had a question like this on the test that you just took. So if I wanted to model 472 plus 545 with base blocks, that would be 4 flats, 7 longs, 4, 5, 6, 7, and then 2 units. And then we would model the second number. We want to add 545, so 5 flats, 4 longs, and 5 units. And then just like we did on the test, show what trades that you have to make. So we're in base 10, so we can't do anything with the units. For longs, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I can take these 10 longs and I could trade them in for an additional flat. And then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 flats. So those would get traded in to make a cube. So we've made all the trades possible. So we have 1 cube, no flats, 1 long, and 7 units. So 472 plus 545 is 1017. Okay. We'll come back to talking about the other bases here in a minute. Another physical model that we used, that we talked about with addition, would be modeling with chips. So our colored chips that we played games with. So if I wanted to model 904 plus 676, 904 would be 9 green, so 1, 2, 3, 4, 5, 6, 7, 8, 9. No blue and 4 yellow. And then I would model my second number, 676, would be 6 green, 7 blue, and 6 yellow. All right, and then I would want to make trades. So 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, we have exactly 10. So those get traded in for a blue. Circle them. All right, and then we have 1, 2, 3, 4, 5, 6, 7, 8 blue, so we can't do anything there. And then 1, 2, 3, 4, 5, 6, 7. Sorry, that's my cat. 8, 9, 10. Green would trade in for a red, and then we can't do anything else with the green. So our answer, we have 1 red. We have 1, 2, 3, 4, 5 in the green, 1, 2, 3, 4, 5, 6, 7, 8 in the blue, and then none in the yellow. So 904 plus 676 should be 1580. Okay. Now, some other methods that maybe you have or have not heard of. Let me actually jump to the standard algorithm first. This is the one that you probably know the best, the one that may be taught in school. So standard algorithm just teaches you to go by place value, starting with the ones. So we do 3 plus 0 is 3, 7 plus 9 is 16. So it says drop the 6, carry the 1 over to the next place value. 1 plus 9 is 10, so plus 0 would still be 10. So drop the 0, carry the 1, and then you have 7, 8, 9, 10. So 2,973 plus 7,090 is 10,063. So we do have some alternatives. So I have 3 of them for addition. The first one is partial sums or expanded. So standard is okay, except for you have to have knowledge of the place value and what is going on. So sometimes it's weird to just think like, okay, just drop a 6 and stick a 1 up there, without necessarily having a discussion about the fact that you have 16 tens. So those 10 tens convert into 100, and that's why we carry the 1. So oftentimes teachers don't talk about that. They just say, oh, just do this. So partial sums or expanded is more of a visual, thinking about focusing on the place value. So 263, if we expand that out, that would be 200 plus 60 plus 3. And then 918 would be 900 plus 10 plus 8. And then we focus on adding each place value. So there is no regrouping, no carrying. So 200 plus 900 would be 1100. 60 plus 10 is 70. And then 8 plus 3 would be 11. So once you have each place value, you can recombine. So we would have 1100, 70 plus 11, so 81. So 1181 is going to be the answer. So 263 plus 918 is 1181. Okay. The next method is called count and strike, or the scratch method. So this method is helpful because you no longer have to keep track of very large numbers. So the idea is every time you make a group of 10, you make a scratch. So normally if we were to do this, we would probably do something like 8 plus 6, which is 14. 14 plus 5 is 19. 19 plus 6 is 25. So that may be hard for a little kid to do when they're first learning about addition. So instead you can break it up, and again, every time you make a group of 10, make a scratch. So 8 plus 6, I said, was 14. So we would make a scratch, and then we would still have 4 singles left over. Then I like to keep a running total. So then 4 plus 5 would be 9. And then 9 plus 6 is 15, which is 10, with 5 singles still left over. So that way you're never getting a number bigger than 10. You're always keeping track. So we ended with a 5, and then we just made 2 scratches. So that tells us we made 2 groups of 10. So that 2 gets carried over to the tens place. So then 2 plus 6 is 8. 8 plus 5 is what, 13. So that's 10 with 3 left over. 3 plus 3 is 6, and then 6 plus 7 would be 12. No, not 12, 13, sorry. So that's 10 with 3 left over. So we ended with 3, and then again we made 2 groups of tens, which would transfer to be hundreds. So 68 plus 56 plus 35 plus 76 should be 235. Okay. And then the third method, alternative method, is lattice. So lattice is getting very popular in multiplication. You may not have seen it for addition, but the way that we do lattice is thinking about what a lattice is, first of all. So a lattice would be sort of like a crisscrossed looking fence. Maybe you see it in a backyard and vines grow up it. So we need to make an answer box of a lattice for each place value. So we're making an answer box, And then I always think of, instead of a lattice, it reminds me of bowling, how you keep score in bowling. But the nice idea about this is that, again, we do no regrouping whatsoever. So 9 plus 5 is 14. And then 2 plus 3 is 5. And then 9 plus 3 is 12. And then we get our answer if we extend this lattice diagonally. We add along the diagonals. So our answer should be, let's see, 2, 5 and 1 makes 6, 4, 1. So 929 plus 533 is 1462. So adding along the diagonal is essentially like carrying over. So think about if you had 12 ones, then 10 of the ones would get carried over to the tens column. So that's what is essentially happening when you're adding along the diagonal. But again, it's nice because kids don't have to worry about sticking the little 1 up there. And anytime you can reduce the amount of work or mistakes a kid can possibly make, that is a good idea. So these are some alternatives you can try with students if they don't understand the standard algorithm. Okay, so now, does this work for other bases? So since they are algorithms, they should work for any base at all. So again, going back to a physical model, if I wanted to do 472 base 8 plus 545 base 8, 472 would be 4 flats, 7 longs, and 2 units. And then if you want to combine that with 5 flats, 4 longs, and 5 units. Okay. So maybe you noticed that I'm doing the exact same problem that I did in base 10, except for I'm changing it to base 8. So my starting picture looks identical. However, the trading is going to be different. So since we're in base 8, we have 1, 2, 3, 4, 5, 6, 7. Can't do anything with the units. 1, 2, 3, 4, 5, 6, 7, 8. So 8 longs can be traded in for a flat. And then 1, 2, 3, 4, 5, 6, 7, 8. So those 8 flats can be traded for a cube. Okay, we've done all the trading we can, so our final answer, we have 1 cube, 2 flats, 3 longs, and 1, 2, 3, 4, 5, 6, 7 units. And that is in base 8. So don't forget your label. Okay, so 1, 2, 3, 7. So again, we've done this before. We did this with base 5 a lot. So base 8 works the same way. All right, let me flip. Oh, not flipping to anything. Okay, so what about the other models? So the chip model, another physical model we can do. So we have 6, 2 in base 7 plus 5, 5 in base 7. So that would mean you have 6 blue chips, 2 yellows, and you want to combine that with 5 blue and 5 yellow. And then now we're in base 7. So 1, 2, 3, 4, 5, 6, 7. We have 7 yellows. So those can be traded in for another blue. And then 1, 2, 3, 4, 5, 6, 7. Those 7 blues can now be traded for a green. And now we have made all of the trades that we possibly can. So our answer is we have 1 green, 1, 2, 3, 4, 5 blue, and no yellow. And then I'm going to cram the base right in there. So 150 base 7. So that's a 7 if you can't read it. Okay. Okay, so then what about the standard algorithm? Standard algorithm, 405 in base 6 plus 424 in base 6. So just like before, so 5 plus 4 is technically 9. So you can't have 9 if you're in base 6. So 9 would be one group of 6 with 3 left over. Then we have 1 plus 2, which is just 3. And then 4 plus 4 is 8. 8 would be one group of 6 with 2 left over. So 1, 2, 3, 3 in base 6 for the standard algorithm. Okay, so what about the 3 that are alternative? Partial sums expanded, not the most helpful thing, but you can totally do it. 4, 3, 4 in base 7. If we were to expand that out, it's going to look very similar to base 10. So that's like saying that you have 4 flats with nothing else, plus 3 longs with nothing else, plus 4 units. And we want to combine that with 1 flat, no longs, and 6 units. So if we had 4 flats and 1 flat, that would make 5 flats, so 5, 0, 0. 3, 0 plus 0 is just 3, 0. And then 4 plus 7 is 4 plus 6 is technically 10. But what is 10 in base 7? That would be one group of 7 with 3 more to make a total of 10. So just remember, you are always doing these problems in the appropriate base. So 4 plus 6 is 1, 3. And then if you recombine this all together, your answer should be 5, 4, 3, base 7. Okay. For count and strike, or the scratch method. So again, before, every time we made a group of 10, we are making a scratch to represent that. So this time we're in base 5, so that means every time we make a group of 5, we are going to make a scratch. So for this one, 4 plus 3 is technically 7, so that would be 5 with 2 left over. And then 2 plus 1 is 3. And then 3 plus 2 is a group of 5. So group of 5 with nothing left over. Okay, so we end with 0. And then we made 2 groups of 5, so those would carry over. So think about making 2 groups of 5 units, so those would trade in for 2 longs. So then 2 plus 1 is 3, plus 1 more is 4. 4 plus 2 would be 6, so that's a group of 5 with 1 left over. And then 1 plus 1 is 2, so we ended with 2. We have 1 scratch, so that makes a trade for a flat. And then we have 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4, 4 plus 1 is 5. So that's a group of 5, so a scratch. We just made 1 scratch. And then 1 plus 1 is 2, 2 plus 2 is 4, 4 plus 1 is 5, so group of 5 is a scratch. And then you have 1 left over, and then we just made 1 scratch, which would trade in. So the final answer for this one is 11020 in base 5. Okay, and then finally, lattice. So if we make an answer block, a lattice, let's see. 8 plus 5, let's see, 8, so 9, 10, 11, 12, 13. So 13 is really one group of 9 with 4 left over. 2 plus 2 is 4. And then 8 plus 3 is 11. So 11, what is 11 in base 9? That would be one group of 9 with 2 left over. So then if we add along the diagonal, our answer should be 1, 4, 5, 2, base 9. Okay, so that wraps up addition. So now let's move on to subtraction. Okay, so with subtraction, again, we have our physical models. So we can start by modeling with base blocks. So if I wanted to do 462 minus 107, if you remember, we always model subtraction using a takeaway method. So we only draw the first number. So 462. Okay, and then I need to take away 107. So I need to take away 1 flat. I'm taking away no longs, but I am supposed to take away 7 units, but I don't have 7 units. So if you remember, we would take one of our longs and break it down into 10 units since we're in base 10. 4, 5, 6, 7, 8, 9, 10. And then we would take 7 away. 1, 2, 3, 4, 5, 6, 7. So our final answer, we ended with 3 flats, 5 longs, and 5 units. So 462 minus 107 is 355. Okay. Our other, done with that page. Our other physical model, I forgot to write it initially, so it's over here. Modeling again with chips. So 327 minus 144. So we would have 3 green, 2 blue, 7 yellow. And we need to take away 1, 4, 4. So we would take away 1 green. We need to take away 4 blue, but we only have 2 blue. So one of these greens needs traded in for 10 blue so that we can take away 4 of them. And then take away 4 yellow. We have enough of those so we don't have to do trades. So 327 minus 144. So let me rewrite it under here since I didn't leave enough room above. We would have 1 green. We have 1, 2, 3, 4, 5, 6, 7, 8 blue, and then 3 yellow. So 327 minus 144 is 183. Okay. Let me jump down to standard because, again, that is one you were probably familiar with. So the regular old algorithm involves some regrouping. So you can't take 9 from 2. So there's a little debate about how you do this. I'll just go ahead and borrow directly from the next place value. Excuse me. So you would take a group of 10, that leaves you with 2 10s, and then that 10 would change into 10 units. So now you would have 12 units. So 9 from 12 would leave you with 3. And then you can't take 4 from 2. So again, you have to regroup. You have to take 100 and change it into 10 10s. So that would give you 12 10s. So 4 from 12 would be 8. And then nothing from 8 is 8, and then 1 from 7 is 6. So 6883 is going to be your answer. So again, that can be a little confusing with students trying to regroup, cross numbers out. So what are some alternative things that you can do instead? So the first method is called counting up. So counting up is a method where we assume that it is difficult for kids to do subtraction, so we are going to change it instead into an addition problem. So with counting up, you want to start with the number 23, the smaller number that you're taking away, and count back up to 11. So essentially, if you think about this as an equation, this is like 211 minus 23 equals something. So if you move the 23 to the other side, 211 is going to be something plus 23. Okay, so that's the idea. So with counting up, you want kids to just be picking numbers that are easy for them to do in their head. So I would not pick anything crazy if I was counting up. Like I wouldn't add like, let's say like 84 or something like that. So it needs to be nice numbers, usually involving making groups of 10 or nice even numbers. So maybe if I started with 23, you can do this in lots of different ways, but maybe I start with adding 7 because 23 plus 7 makes a nice number. It makes 30. From 30, maybe I could add 70 because 30 plus 70, that's a nice easy 100. From 100, maybe I add another 100. So now I'm up to 200. And then I can go ahead and just add 11 because 200 plus 11 would be 211. So then my answer is all of these little partial sums that I just did. So 7 plus 70 plus 100 plus 11 is going to be, what, 188. So 211 minus 23 should be 188. Okay. So counting up. Okay. Another strategy is equal additions, and there are two different ways that you can think about equal additions. So type A is thinking about adding by the base. So this method is also called European addition, so it's how most of Europe does addition. Or, sorry, it's how most of Europe does subtraction through equal additions. So the idea is instead of borrowing, they are adding to the problem to make it easier to do. So, so here's how this works. So you can't take 2 away from 1. So what we would normally do is we would take 8, change it into a 7, and we would take that 10 in order to make 11. So again, instead of regrouping, we're just going to add 10. So adding 10 gives us 11. Now the problem is we've just changed the problem. We've added 10 to the top quantity. So to maintain the difference, you also have to add 10 to the second quantity. So think about if these two numbers are a certain distance apart on a number line, if you move one of them up a little bit to maintain the difference, you would have to move the second number also up. So you're moving them equally along the number line. So we don't want to just add 10 ones because then that gives us a problem where we have to take away 12 from 11. So instead we add 10s, a group of 10. So now we have 5 10s. So we added 10 singles and then a block of 10. So then 2 from 11 would be 9. And then we want to take away 5 from 8. So that leaves us with 3 and then 1. So 281 minus 142 is 139. Okay, the second method then of equal additions is where you can just add anything that you want. So again, it's this idea of maintaining the distance on a number line and like moving the problem up at the same rate so that it is easier to do. So right now, if you have 281 minus 142, it's going to require some regrouping like we had to do over here. So instead, what can we do to make this problem a little easier to do? So it would be nice if instead of taking away 142, maybe we changed it to, what if we could take away, let's say 150. So in order to do that, I would have to add 8 to the amount that we're taking away. So to compensate and maintain that distance, we would add 8 to our original starting amount. So that would bring us to 289. And then all is right in the world because now we have a simpler problem that requires no regrouping. So you may have to do this a couple of times, but in this case, 2 minus 1 is 1, 8 minus 5 is 3, 9 minus 0 is 9. So you still get 139 as an answer. All right, next one. So next alternative, so we have counting up so far, equal additions in 2 different ways. So method of complements. This is my favorite one of all time because it looks kind of like a magic trick. So if I want to take 3002 minus 1875, if you think about this right now, we're going to have to do lots of regrouping because we can't take 5 from 2, you can't take 7 from nothing, and you can't take 8 from nothing. So instead, we start by thinking about what is the largest possible number we could use that would eliminate regrouping completely. So that number in this case would be 9,999. So what if we actually change this problem to 9,999 minus 1875? So 9 minus 5 is 4, 9 minus 7 is 2, 9 minus 8 is 1, 9 minus 1 is, oh, not 10, sorry, 8. Ooh, I'm ahead of myself. Okay, so 8,124. Then we kind of forgot about the 3002. We changed the problem. So next step is to add the 3002 back in. So you get 6, 2, 1, 8, 9, 10, 11. So now we have 11,126. so here's where the magic happens. For the final step, we are just going to eliminate this 1 that leads the number. We move it to the ones place, and then we're going to add. So I'm a little bit out of room, but if we add this together, our final answer should be 1127. So 3002 minus 1875 is 1127. Maybe I can jam it in here above my words. 1127. Okay, so the way that this works, like I said, it kind of looks like a magic trick, but think about what we're doing. So we're just starting with 9,999. We're doing minus 1875. We got that answer. Then what did we do? We added 3002. Then what did we do? We scribbled out the 1. So by scribbling out the 1, that's like essentially subtracting 10,000, because we were going from 11,126 down to 1,126. So we're taking away 10,000, and then we took that 1 and we added it. So plus 1. So if you think about the process we're doing, what is negative 10,000 plus 1? So that right here is equivalent to negative 9,999. So if it's negative, that cancels out the positive 9,999. So we're really doing a negative 1875 plus 3002, which is the same thing as 3002 minus 1875. Okay. So again, looks like a magic trick, but it's not. All right, and then finally, partial difference or expanded. So this is similar to what we did for addition. So we have 5,000 plus 400 plus 50 plus 5. And we're subtracting 4,909. Okay, so again, no regrouping. We just look at the place value. So 5,000 minus 4,000 is 1,000. 400 minus 900 would be a negative 500. 50 minus 0 is 50. And then 5 minus 9 would be a negative 4. So then we have to do a little math in order to figure out our regrouping of our answer. So 1,000 minus 500 would be 500. And then 50 minus 4 would be 46. So our answer should be 546. So 5,455 minus 4,909 is 546. Okay, so what about other bases? So, and we'll almost be finished. So other bases. So again, going back to the physical model, so we have 1, 2, 1, 2, 1, base 3, and we want to take away 2, 0, 1, 2. So we've never done this before, a 5-digit number, but after the place value, think about they're increasing by 3. So it would take 3 units to make a long. So this is a little misleading because the picture would not be correct, right? It would take 3 units to make a long. It would only be that big. Then 3 longs would make a flat. So this would really just be a 9 by 9. So let me maybe like scribble some of this out to represent that. It would be much smaller, right? And then your cube would also just be 3 by 3. So it's going to look something much smaller, like right here. Okay, so you get the idea. And then it would be, the next place value would then be 3 cubes grouped together. So it's just a grouping of 3 cubes since we're in base 3. Okay, so 1, 2, 1, 2, 1 would mean you have this group of 3 cubes. So one group of 3 cubes, 2 individual cubes, 1 flat, 2 longs, and 1 unit. Okay, in base 3. And then we need to take away, so need to take away 2 cubes. We need to take away no flats, 1 long, and then we would need to take away 2 units, but we only have 1. So take our other long, that would trade in for 3 units. So if we take 2 of them away, our answer, we would have a group of 3 cubes, no single cubes, 1 flat, no longs, and 2 units. So 1, 0, 1, 0, 2 in base 3. So again, we have done this before. All right, let's look at alternatives. Let's see. So another physical model is the chip model. So 7, 0, 4, 1, 3 in base 8 minus 6, 7, 7 in base 8. So again, beyond the red chip, the next place value is black. So we would have 7 blacks, black chips, no red, 4 green, 1 blue, 3 yellow. And then we're going to have to do a whole lot of trading. So we need to take away 6, 7, and 7. We don't have enough of any of that. So we would start by taking one of our black chips, trading it in for 8 red, since we're in base 8. Then let's just do all the trading we need. So then one of the reds would trade in for 8 green. We need one of the greens to trade in for 8 blue. And then we need one of the blue to trade in for 8 yellow. Just doing all the trades at once. Okay, so then we can take away 6 green. We can take away 7 blue and 7 yellow. Okay, so we want to take away, so what are we left with? So we have 1, 2, 3, 4, 5, 6 black, 1, 2, 3, 4, 5, 6, 7 red, 1, 2, 3, 4, 5 green, 1 blue, and 4 yellow. So our answer should be 6, 7, 5, 1, 4, base 8. Okay. Let's jump down to the standard algorithm, the one that you probably already know how to do. So we can't take 8 away from 1, so we should regroup from 0, but we don't have any available to us. So we got to go all the way to the flats. So we would take 1 flat, that would trade in for 9 longs. And then while we're making trades, one of the longs would need to trade in for 9 units. So you have 9 units plus the one you already have, so this will become 10. So 8 from 10 is 2, 2 from 8 is 6, and then 6 minus 6 is 0. So standard would be 6, 2 in base 9. Okay. All right, so how would the others work, the non-standard algorithms? So for counting up, again, we would start with 2, 4, 2 in base 5. So we're trying to get to 3, 1, 3. So what I would do is maybe start trying to get to the flats first. So what if we just add 3 units? If we add 3 units, that would become a 5. So then that would trade in for another long. Then you would have 5 longs. The 5 longs would trade in for a flat. So this would become 3, 0, 0. Okay. And then from there, I'm actually going to do this in 2 steps. I could add 1, 0. So 1, 0 in base 5. This is not 10. This is 1, 0. So that is like adding a long. So that would give you the number 3, 1, 0. And then we can add the 3 units to make 3, 1, 3 in base 5. So our answer, if we took 3 plus 1, 0 plus 3, that would technically be 1, 6. The 6, though, we're in base 5, so that would trade in for another long, so that would be 2, 1. Base 5 would be the answer. So 2, 1. Okay. What about equal addition? So adding by the base. So you can't take 4 away from 1. So I'm going to add 5 to this top number. So 5 units plus the 1 unit we already have would make a grand total of 6. Then we also need to add 5 here. So instead of adding units, we would add 5 in terms of a long. So this would turn to having 3 longs. And then we don't need to make any other trades. So 4 from 6 is 2, 3 from 3 is 0, 1 from 3 is 2. So 2, 0, 2 in base 5. Now, what if we wanted to change this and just add anything we wanted? So 1, 2, 4 is going to require regrouping. So instead, what if we do something simple where we just add 1 unit to each? So this would become 1, 2, 5. So the 5 would trade in again and make a long. So this is really 1, 3, 0. And then 3, 1, 3 in base 5 plus 1 more would be 3, 3, 2. So subtracting, you get 2, 0, 2. So no regrouping whatsoever. Okay. For method of complements, so again, think about what is the largest number you could possibly use in base 5 so that no regrouping is possible. So that would be the number 4, 4, 4, because you can't have 5 of anything. So I would change this to 4, 4, 4 minus 1, 4, 3. Okay, subtract, so we got 1, 0, 3, so 3, 0, 1. Next step is to add the original number that we changed. So if we add 2, 3, 2, makes 3, 3, that would be 5, which would be 0, 1. Those would trade in. And then final step, scribble out the 1, magically put it in the 1's place. So our answer for this one should be 3, 4 in base 5. So 2, 3, 2 in base 5 minus 1, 4, 3 in base 5 is 3, 4 in base 5. All right, and then last one, partial differences. So we have 3, 0, 0 plus 5, 0 plus 2 minus 1, 0, 0 plus 5, 0 plus 5. So 3 flats minus 1 flat would give you 2 flats. So 2, 0, 0. 5 longs minus 5 longs gives you nothing. And then 2 units minus 5 units gives you negative 3. So then again, you have to do some math to figure this out. So this is like we have 2 flats right now and we need to take away 3 units. So that means a flat would have to turn into 6 longs. And then the longs would have to turn into 6 units. So if we take 3 of them away, we are left with a combined answer of 1, let's see, 5, 3 in base 6. So 3, 5, 2 in base 6 minus 1, 5, 5 in base 6 is 1, 5, 3. All right, so then in the next video, we are going to be talking about multiplication and division algorithms. So thanks for watching. I know this was a really long video, so thanks for hanging in there.